Hello everybody. Today what we're going to do, we're going to talk about piecewise applications. So we've talked about piecewise function as basically taking, we're restricting the domain for different parts of an equation. And so now we're going to do that in like a word problem. So we're going to talk about Social Security taxes. So if you earn up to $113,700, your you're going to be taxed at a rate of 6.2%. So that's what you're going to donate into the Social Security system in the year 2013. If you make over $113,700, you're going to pay this flat rate of $7,049.40. So what we want to do first is write a piecewise function that matches that equation. So remember, we start off with our big bracket. So there's going to be two pieces. There's this part up here that's the 6.2, and then there's this part right here that breaks down the 7,049. So if we're going to first thing we want to do is look at kind of restricting the domain. So our domain is going to be, our X is going to be the income, and our Y is going to be the amount that we pay in taxes. So I'm going to put my little f of X over here, and it's equal to two different equations. So our first equation, I'm going to restrict the domain. It's going to go from $0, so if you don't make anything, and we're going to include that point, X, and then all the way up to $113,000, $113,700. So it says if you earn up to this. Then if you earned over that, that's going to be in the other part. And so here we're saying that we're going to stop at 500,000. So we're only worried about people that make between 0 and 500,000. So our next domain is going to be restricted from here. But so right here we go less than, since this was less than or equal to. So to make sure that it's a function, I can't have those two things overlap. So this cannot be the same as this. So this is less than or equal to. It could go the other way, but you got to pay attention to the wording in the problem. And then we're going to go up to and including $500,000. Normally that would just go on forever, and we could just say X is greater than $113,700. And over here, we're going to say that you're not going to lose any money. So we're not going to say your income is going to be negative. So then we would go to our equations. So our equations are going to be, the first part is we're taking 6.2% of our income. So we change that decimal, or that percent, to a decimal, so 0.062. And then we're going to multiply that by our income. Our income in this case, we use the variable X. You can use whichever variable you want. But basically that's going to, anything between 0 and 113,700, we're going to take that amount, multiply by 0.062, and that's going to give us our answer. Now, if we make between 113,700 and 500,000, we're going to make this $7,049.40. So that's how much we have to pay. So it's capped at that amount. So we can't pay any more than that. So let's answer it. So that's our piecewise function that matches our problem. So now what we're going to do is answer some questions about it. So the first question that's asking us is how much Social Security tax would somebody who made $50,000? So $50,000, what we want to do first is look at the domain. So if we're looking at our equation here, our domain of $50,000 is going to fall between 0 and 113,000. So that means we're going to use this equation. If it was between this and this, we would use this equation. So we're going to do 0.062 times our income, which is $50,000. And we don't have any y-intercepts or anything, so you just put that in your calculator, and you get $3,100. So if we made $50,000, we're putting $3,100 into the Social Security. If we made, let's say we put in $4,000, so then we want to figure out how much income we had. So $4,000, what you're going to look at here is that as our Y. So Our y, $4,000 is less than the $7,000, so we know it's going to be somewhere in here. So I'm going to use this equation here. But I know that this $4,000 is my y, so I'm going to set up a little equation. So $4,000 equals 0.062 times x, and then we just solve for x. So just divide by 0.062, and you get 64,000, oh, not a decimal, period, 516.13. So if we paid $4,000, this is how much our income would have been for that year. All right, then our last question from this part. What is the meaning of if I have f of $150,000? So f of this is what our income is. So the meaning of this is a person, this is how much taxes somebody would pay if they earned $150,000. And then remember back to our original equation, if they made between $113,700 and $500,000, they would pay that $7,049. So to find this value, we just say f of 150,000 is equal to that $7,049.40. So that is piecewise applications for that. We're gonna go through one more really quickly. So this one has a little bit of a graphing function with it. So we've got a snowstorm. Meteorologist is tracking how much the snow is accumulating. For the first 3 hours of the storm, it's falling at a constant rate of 1 inch per hour. So, and then the storm has stopped for 2 hours, and then it started again at a constant rate of 0.5 inch per hour for the next 4 hours. So let's graph it to start with. So our first part, it says the first 3 hours of the storm. So that's restricting our domain to this first 3 hours. We have no snow accumulation at the very beginning of it. So I'm going to put a dot right there. And then it's accumulating at 1 inch per hour. So my snow is accumulating at 1 inch per hour. So my slope is just 1. And it is accumulating for 3 hours. So that is the first part of my graph. So that's that first part of the storm, that first 3 hours where it's snowing at 1 inch per hour. Then it says the storm stopped for 2 hours. So that means there's no snow accumulation for those 2 hours. So from 3 to 5, there's not going to be anything. So if I want to think about this as 3, and then there's the 5 hour mark. Okay, and then after that, we have that started again at a constant rate of 0.5 inch for the next 4 hours. So the next 4 hours, so that's 5 to 9, we're going at 0.5 inch, but remember we didn't lose anything, so we're still at 3 inches accumulated for the snowstorm. And we're following our slope, so we're going up 1 and over 2, and then up 1 and over 2. And so there, and it doesn't say anything else, so we're just going to put a little endpoint there. We're not going to say it keeps on going on forever. So we got a little 9 hour snowstorm. So now what we want to do is write the piecewise that matches this. So there's a little bit of a tricky part for this one, but the rest of it should be pretty straightforward. Now, in this part, there are actually 3 sections to our graph. So the first part is going to be just this first part. So we know that the slope was 1, and I'm multiplying times x. X is going to be the time in hours. So every hour, I'm adding 1. And our domain is from 0, less than or equal to x, is less than or equal to 3. So at 3 hours, I should have 3 inches of snow accumulated. Then here, I'm sticking right there at that 3. If I kind of drew it across, that should be 3. So the next part is just 3. And I am going from this 3 hour mark to this 5 hour mark. So I'm going to include that second part. So remember, this is not equal to, this is equal to. So these can't be the same. So you can either do this one is equal to or that one or equal to, but it can't be both at the same time. Then now we're going to do the last part. So we know our domain is restricted to the last 5 hours. It can't be the same as that one. So we have from 5 hours to the 9 hours. We know that our slope is going to be a half. Now, the thing is that we have to figure out, if I'm writing this equation, I can't just say 1/2 x. Because if I have 1/2 x, it's just going to leave from here and not match up with this. So we have to figure out where the y-axis is, or the y-intercept. So the easy way to do this is think about that vertex form for the quadratic, but we're going to do it as like a linear function. So the way that we do this is you're going to say 1/2, and you're going to put a parentheses, and then think about this. We're going to go to this point. So we're trying to figure out that point. So I'm going to do x minus, normally it'd be like x minus h, and then we put the parentheses and the plus k. So that h is how much is shifting right or left. So we shifted it to the right 5. So you're going to do minus 5 because we shifted it to the right 5. And then we shifted it up 3 to get to there. So this is kind of like the vertex form of a line, if you want to think of it that way. And then what you could do is then simplify this by distributing that 1/2 and then adding your like terms. So you could also have, I'm going to write this in a different color. So let's say I'm going to write a little or. It could be 1/2 x plus 1/2 if you simplified it. So that is our piecewise equation. So now let's answer our questions that we have for this. So you can either use the graph or the piecewise function for this. But it says, when will the depth be of the snow be 4 hours or 4 inches? So that's telling us that our y, so we're looking over here. Or we can go to this equation, and we can just simplify that. So if I did the graph, if I go over here to 4, I go out here, I'll go to 7. Or we can think about it as that 1/2. I'm just going to use the simplified version. I don't know how much time there's been, but I do know that it's equal to 4 inches. And so then we solve that, solve for x. So you subtract the 1/2 and then divide it by 1/2. You should get the x equals 7 hours. So 7 hours into the snowstorm, we're going to have 4 inches of snow. And then it says, how much snow will there be on the ground after 4 hours? We can either use the graph. So the graph, we go over here to 4, go up, find that that's going to be 3. Or you look over here at our function here, and you see that 4 is between 3 and 5. So then you just substitute that 4 into that equation, and you're going to get 3. So we get 3 inches after 4 hours. And that is piecewise applications.